Hello, and welcome to Linear Inequalities. This is a college algebra review, but I gotta tell you, there are not too many higher versions of linear inequalities. A linear inequality in one variable is an inequality that can be written in the form ax plus b is greater than 0. It seems similar, very similar to a linear equation. The only difference is the inequality sign. A cannot be 0, or else we will not have a variable, and we could use any of the four inequality symbols. Now, there are properties of inequalities just like there are properties of equations. If a, b, and c are real numbers, then we can add or subtract because we can add a negative value. We can add or subtract the same thing to both sides of an inequality, and the inequality remains the same. If we have a positive number, then we can multiply on both sides of an inequality, and the inequality remains the same. But if we have a negative number, then multiplying by a negative switches the direction of the inequality. And because c could be a fraction, that means multiplying or dividing by a negative will change direction of our inequality. If we look at a number line, we can see why that is. Wow. That was weird. Okay, we can easily see that 1 is to the left of 2, less than, left of. All right, left of on the number line equates to less than. But with the negative numbers, it's still negative 2 is less than negative 1. But notice that when we change the sign, it becomes the opposite. The 1 is now less than the 2 instead of negative 2 being less than negative 1. So that's the reason for this rule. It's because of our number line. All right, let's use that. Let's solve some linear inequalities. For number 1, 4x minus 1 is less than 3 minus x over negative 3. Anytime I have a denominator, I choose to multiply by that denominator. Because it's negative, I have to change this direction of the inequality. I'll have negative 3 times 4x minus 1 is now greater than 3 minus x. The negative 3 is canceled out, and I need to distribute on the left. So I'll have negative 12x plus 3 is greater than 3 minus x. Now I'm going to add and subtract on both sides. When inequalities are around, I'm always going to take my variables to the left. It hurts my head to do it any other way, so I try to remain consistent when it comes to inequalities. I'm going to subtract 3 from both sides, and now I'm going to be super disappointed. 11x is greater than 0 if we divide both sides by a negative 11. Because we divided by a negative, we switch the direction of the inequality one more time, and we get x is less than 0. I'm going to show you a little quick trick here. If we are to go to a y1, let's look at the left side of this equation. That's 4x minus 1. And on the right side of the equation, we have parentheses 3 minus x divided by a negative 3. So I'm going to graph the two of these. And at first we're thinking, wait, which one is which? So we can easily differentiate these by going to the far left-hand side. I'm going to make the right-hand side a thick line. So there's y1, there's y2, and we can see when is 4x minus 1, the thin one, below the thick one? Well, it's up x values less than 0. So we can make sure that we chose the right part. We switched our inequality 2 times, but we still got the right answer verified graphically. All right, on this inequality, let me change colors just so it sets apart from the eye a little bit. We have a negative 3y plus 12 is greater than or equal to 2 minus 4y. Let's add y's to both sides. Let's add 4y to both sides. And let's also, if I'm adding 4y to the left, let's subtract 12 from the right. Subtract it on both sides, all right, but we want to take it over there. So negative 3y plus 4y is y, greater than or equal to 2, and a negative 12 makes a negative 10. Notice this inequality did not change, because even though I subtracted, right, that doesn't change the direction of the inequality, or the fact that my result is negative, that doesn't change the direction of the inequality. The only thing that would happen, the only thing that would change, is if we multiply or divide by a negative, and we didn't do that here. All right. If we want to solve graphically, let's just go back here. Similar to the first one I showed you, only this time there's no work to write down. Negative 2x is on the left. On the right, we'll have a negative 5/3 x. Since I did not use parentheses, my calculator is not putting that x down with the 3. It's assumed to be a separate thing unless I put parentheses around the 3x, and then it'd be wrong. I'm going to make the second line darker, so the right hand side is darker. I'm going to write this over here. Y1 equals negative 2x. Y2 is negative 5/3 x plus 1. Y1 is a thin line, and Y2 is a thick line. And we can see over here in our graph that that's kind of horrible. So let's zoom in. Just zoom in at the center. I can see now my intersection is up here off the screen, so I need my y values to increase. Let's change our y maximum to be about 6. Guessing. Where did I get that from? Just a number I thought of. And now I see my x value is not big enough, so I change my window. This is one of those things where Desmos, if I would have pulled up Desmos to do this, it is so much easier to scroll and find. Actually, so much easier, in fact, that I would really like to have pulled that up. I still need to go up more. So instead of a drag and drop, I have to keep playing with this. My x values seem fine, but I don't want to keep playing too much more. Y value, let's take it up to 10. Let's see what the graph looks like. Okay, so we can see an intersection somewhere around here. And we want to know where is the thin line greater than or equal to the thicker line, greater than, so above. So when I find my intersection, I'm going to calculate an intersection. I need to hit the right buttons. 5, intersection. First curve is y1. Second curve is y2. And that's pretty close to my guess. The intersection is at x equals negative 3 and y equals 6. So what's our answer here? Keep in mind the original problem only has x values, so it happens to be y equals 6 that we need. Now, which part of this? On a number line, if we only look at the x values here on our coordinate system, here we have negative 3. Where is the thin line greater than or equal to the thick line? And that is on this side, on the left side. So we find that x has to be less than or equal to negative 3, or in interval notation, do it correctly, we will have negative infinity to negative 3 square brackets because of the or equal to. Whew. Checking it is a whole lot easier than explaining how to solve it using your calculator, but either way they can be done. We also have things called compound inequalities, and inequalities will be huge when you take calculus, and I really hope that you all go on to take calculus so you can appreciate how much easier calculus is than algebra, in my opinion. But a compound inequality occurs when two inequalities are connected by the word and or the word or. When the and connects two inequalities, they can sometimes be written as a three-part inequality. So instead of doing things to both sides, you do things to both, or to all the parts. So of course I give you a difficult one to start because that's how I roll. I want to get this -4 away from the x in the middle. So I have to make sure I balance that by subtracting 4 from all of the parts. The left side, have my less than or equal to symbol. And on the right side, 20 minus 4, I almost divided. Make sure you're remembering you are subtracting 4. And now to get this x completely by itself without a negative, we have to divide by -1, and we end up with 1. Because this was negative, our inequality switch orders. And, let's do this correctly. That's a -16. And you might think you're finished here, but you are not finished. When you're writing inequalities, always keep the number line in mind. We always want to write from left to right. So if I have a -16 and I have a 1, I want to make sure that I write my answer in that form. -16 is smaller, it's on the left. It should be on the left of the inequality as well. This inequality is pointing at the -16, so when I rewrite it, I make sure it points. X is still in the middle, and this inequality points at the x to land on 1. And here we have our interval. All right, so it's compound, it's in between the values. So this answer, 1 greater than or equal to x greater than or equal to -16, is not going to fly. Your compound inequality should always be written with less thans. If greater thans happen, we need to rewrite the order. All right, one more. Let's fractions, right? Am I right? So let's multiply everything by 4. 4 times 6, 4 times 3/4, 4 times a half x, 4 times 3. And when we do that, we'll get 12 is less than 2x plus 3, which is less than or equal to 24. At each stage, ask yourself, did I multiply or divide by a negative? No. So my inequality should remain the same. Notice on the left is 12, on the right is 24. Our order for a number line is preserved. Now we can subtract from each part. 12 minus 3 is 9. Less than 2x, less than or equal to 21. Now I'm going to divide by 2. This 2 is a positive 2. So I'm just going to leave it. 9 halves less than x less than or equal to 21 halves. We could put this on a number line as I did up in example 1, or we could throw it in interval notation. Keep in mind that or equal to will always have square brackets. If there's no equal to, they're round brackets. Parentheses for normal people. That's it for linear inequalities. Thanks for listening.